Here's the robot. All 6 legs, well, 5 of the 6 are on the ground right now, and it is secured, as you see, to basically a rope pulley going up to a joist. This is to prevent it from falling over accidentally, which has helped already in some of this additional testing. At this point, what I'm doing is I have all the legs down, with, well, except for number 2, but when I did this, I found out that leg 1, 3, and 5 were holding all the weight, but 2, 4, and 6 were not. So what I'm doing now is calibrating these guys. So here's leg number 6, and one way you can see here is that it's, in this case, it's not even touching the ground. So what I'm going to do is do some mechanical and electronic calibration on this leg to get it to touch the ground without having the adjacent legs being lifted up, so that these guys are all on the same level at this point. So what I've done here is I've removed the nut from the shaft for the encoder, so I can go and pull that, which releases this. Now I can rotate this shaft and give it 2 or 3 turns, and we'll see how, and we'll test it again and see how that works. Okay, the calibration process basically involves just going back and forth, changing the how far this shaft is extended, and then seeing whether or not it's solid on the ground and it hasn't caused the other 2 to loosen up on either side of it, which tells me they're basically, all 3 of these together are even, and if you go all the way around, all of them would be even. But it's a lot of back and forth, plus the calibration on the encoder changes because the angle becomes different. And here's the encoder right here, and the angle that it's measuring right here changes as we go along. So a lot of back and forth, but now I've got all 6 legs are calibrated to the same spot at this point. And as you see, the robot actually is standing on its legs at this point.